The universe is mostly empty space called a vacuum. All the stuff in the universe that isn't space is made of matter. Stars, planets, people, ferrets, beach balls, even that plastic nubby thing on the end of your shoelaces. It's all matter. The amount of matter in each of these objects is called its mass, and we use a balance to measure it. The balance measures in grams. A gram of matter is about that of a thumbtack. Now here's an empty party balloon. The balance reads
11.7 grams.
Now let's put some air inside and take another measurement.
15.8 grams. That's a difference of 4.1 grams.
As you can see, the air inside has mass. Everything, even the air we breathe, has mass. Sir Isaac Newton tells us that there is a force of attraction between all matter. He called it gravity. Gravity is the force that can be found between any two objects. This means everything is being pulled on by everything else in the universe. This sounds like a science fiction movie where you could cause objects to fly to you on command. But in reality, things attracted to us are more attracted to the Earth. Newton says you're attracted to the sun, but when you jump into the air, you fall back to Earth. This is because even though the sun is more massive than the Earth, it is too far away to pull you from Earth's gravity. We can calculate the amount of gravity using Sir Isaac's equation. For example, the mass of the Earth will go here in the equation and the mass of the sun here. The distance between the sun and the Earth goes on the bottom of the equation. Let's look at what happens if we change things around. If the mass of one of these objects goes up, so will the gravity between them. If the objects get further apart, the gravity between them gets weaker. Sometimes it gets so weak that we say you're in zero gravity.
It's probably not true that there's absolutely zero gravity in space. Gravity is a force that arises from large masses. The mass of the Earth has a gravitational pull, and that pull is a force. As we get further and further and further away from the Earth, that pull is lower and lower and lower. Now, if we were to continue to go out in space and start getting close to Jupiter, okay, then we would begin picking up the gravity of Jupiter, because it's a larger mass that would actually be a greater pull.
Usually we talk about the gravity between you and the Earth. You have mass. The Earth has mass. So therefore, there is gravity. If we stick a bathroom scale between you two, it measures the force of gravity on you. And we call this force your weight.
The mass of this pin is how much matter is in this pin. This is 100 grams whether or not I hold it in my hand here, or I carry it to the top of Mount Everest, or if I take it out into space. It's still 100 grams. Weight, however, is a measure of the pull that the Earth has on us. Its weight is greater here than it would be on Mount Everest than it would be in space. Essentially, it would weigh almost zero in space.
Time for review. When we talk about the weight of something, we are describing a force and not a mass. All matter is made of mass, and all masses are attracted to each other. This force of attraction is called gravity. The force of gravity between two masses is called the object's weight. Usually one of these masses is the Earth. The other could be you, a boat, hot air balloon, anything. All of these things have weight because they are attracted to the center of Earth.